Yes, members, welcome back to our YouTube channel. It's still Shaka Anwar, the math tutor. As I promised you that I'll bring for you a sample question to see how we can answer different questions and different subheadings we had in the previous video. Today, let us talk about this sample question. It's saying that consider the pricing of share prices movement of Sahari. I think the Sahari is a company using the three-state Markov chains. Each closing day share prices are classified into a decrease D, unchanged U, and increase I. The summary of 1A trading days data panel of the daily closing prices of Sahari shares is this one. Here it is a decrease, and unchanged, and then increase, unchanged, increase. Now questions are: write down the transition probability matrix, 3 marks. We sketch the transitional graph, 1 mark. What is the probability that the investor's value of his stock will increase consecutively over the next 4 days? 2 marks. Then suppose the initial state vector is given by, they have given us the initial state vector. I think they have given us the probabilities for each given state of increase, decrease, and unchanged. Calculate the state probabilities of the 4th day closing. Not just find the state probabilities of the initial day closing. Not just find the probability that on the 4th day, what's the probability that it's going to a decrease, increase, and unchanged. I think for all these questions, we have seen them in our previous videos, and then we shall answer them with ease. Now let us begin with question 1. I write down the transition probability matrix for each. We say that what we need to know that the summation of the row of a given transition probability has to add up to 1. Therefore, if I try to write my Pij here, just a matter of having, I'll have D, U, and I here, but remember a sum of the row has add up to 1. Therefore, what I need to do is just I need to find the sum of the whole of this row. Then I say 120 divided by the sum, 60 divided by the sum, 59 divided by the sum. I'm saying that if I try to add the whole of this row, the sum of the row is going to be 102 plus 65 plus 59. I'm going to have my answer as 226. Therefore, now for me to get the value to go here, PDD is going to be 102 divided by 226. I'll have 0. I think that's right to 3 decimal places, 0.51. Then now for me, I have PDU going to be 65 divided by 226. I'll have 0.288, and then for me to have PDI is going to be 59 divided by 226, and that will be 0.26, I think, 1. I have to make sure that if I add the whole of the row, I need to get 1. Let me try to see. 0.421, 0.451 plus 0.288 plus 0.261. It has to add up to 1. My row is adding up to 1. Therefore, I do the same thing for other rows. And if I add the row here, then I get the total. What's the total for here? 64 plus 168 plus 62, the same as having 294. Now to get the value to go here, you just need to have 64 divided by 294. 64 divided by 294. I'll have 0.218. Yes. Now it's now 168. 168 divided by 294. Here I have 0.5. 0.57, then 1. Then what's now 62 divided by 294 is going to be 0.21, and then I think a 1. Now if I add these, I have just add up to 1. Let me try 0.218 plus 0.571 plus 0.211 is exactly 1. I do the same thing here down. If I add 68 plus 50 plus 103, I'll have 221. Therefore, yes, I get 64 divided by this one, I get the answer here. This will be 68 divided by 221. I'll have 0.308. Yes. Now 50 divided by 221, I'll have 0.226. Yes. Now 103 divided by 221, I'll have 0.46, then a 6. Now if you try to add, I have 0.3, 0.3, 0.308 plus 0.226 plus 0.466. I have a typical one, and therefore this is going to be my transitional probability matrix number 1. I get my 3 marks just by doing this. Now the other question 2 is telling us to sketch the transitional graph. We say the transitional graph, we need to just first define our states. Remember, our states is either D, yes. We need to have a U unchanged, and then I, which is increase. Now, our transitional probability is going to be just that way. Now, what do we have to do? It's just us now allocating arrows. Say now, I'm coming from D to D. It's going to be 0 point this one. Therefore, D to D, because remember this is DD. D to D is coming from D back to D, which will be 0.451. Yes. Now, I'm coming from D to U. I'm coming from D to U. It's going to be 0.288. Now, I'm coming from D to I. From D to I. Is it? Yes. It's going to be D to I. Let me make it more visible. D to I is going to be 0.26, then 1. I think that's where they are now. Here I'm coming from U to D. From U to D, it's going to be 0.218. Then from U to U, I'm coming from U back to U. It's going to be 0.571, 0.571, and then from U to I, from U to I is going to be 0.211. Now I can come back now. From I to D, I'm coming from I, going to D. It's going to be from I to D. It's going to be 0.308. Yes. Now I to U, coming from I, going to U, going to be 0.226. And then from I to I is going to be 0.466. I think now, just you knowing how to get your transitional probability matrix and now how to sketch the transitional graph, you are able to earn yourself, I think, 5 marks. I think these are the simplest things we have been doing. Okay, now let's go for another question. Part number 3. They say, what's the probability? What is the probability that an investor's value of stock will increase consecutively over the next 4 days? I think here I say that for the 4th day it has to increase, third day has to increase, 4th day has to increase, and then the 1st day has to increase. I think that they're giving us a pass to pass through. Therefore, if I give us a pass to pass through, I think I can easily remove this because you have already copied it. If I remove off this, I need to create space where to answer questions from. They are saying that they want us to get the probability. What's the probability that the investor's value of stock will increase constantly over the next 4 days? They are saying that probability that on the 4th day it will increase, probability that on the 3rd day it will increase, probability that on the 2nd day it will increase, probability that on the 1st day it will increase, provided that on the initial day it was increasing. This is what they want. The probability of a path. And then you say that the probability of a path Remember, if you're not given a condition, you have to multiply times the probability of the initial state being I. Therefore, this is just the same thing as having probability of, yeah, this is not the same as this. This is done. This is the same as having probability of x4 equal to I, given x3 is I, yes. Now times probability, yes, of now x3 equal to I, yes, given x2 equal to I, now times probability of x2 equal to I, given x1 equal to I, times probability of now x of x1 equal to I, given x0 equal to 1, equal to I, not once. This is I, equal to I, then times the probability of x0 equal to I. Since we have no condition here, therefore this is the same thing as having, I'm coming from I to I. I'm coming from I to I. From I to I is 0.45, 0.451, but it's the same thing. This is I to I, I to I, I to I, I to I. I'm coming there 4 times. This is just power 4 times probability of x not equal to I. Therefore, my answer is going to be 0.451 power 4 times that answer is going to be 0.04, yes, 1, I think, 4 probability of x naught equal to I, because we don't know what probability of x naught equal to I is. I think also for this is just simple, as we saw it in the previous video, that probability of a path, you just need to consider a given path, but we shall always determine the future given the present, and we shall ignore all the past. Now I think we get this answer. Those people whom we have been moving together, we can easily get this answer. If you feel that you're not connected with this answer, just go to the previous video. You will see how we got to this answer. Then, lastly, our question is saying that suppose the initial state of the vector, of the state vector, is given by 0.315, 0.8, 0.841, 0.2991, and then this is the probability of a given state. The probability of decrease is this one, probability of unchanged is this one, and probability of increase is this one. Now they're saying that calculate the state probabilities of the fourth closing day. One has to find the x equal to 4. One has to find the state probabilities on the fourth closing day. I think also I can put off this here at first, get space what right. Now, as we say that they want us to find the probability of x equal to 4. Let us say probability of x4 equal to dash. Okay, x4 may be either decrease, increase, or may either be increase, decrease, or increase, unchanged, or increase. Yes. Now here we say that this is the same thing as having pi, but now here we have nothing like today, because we don't know, we have all the states here, and then we have here now, but now here it is 4. This calls for us to also get, this is the same thing as having the pi naught we had times the p power 4, and then we're reading all the values of the d, u, and I. I think we have together also on that step. Now our task here is finding p power 4, yes. After getting the p power 4, and then our last task is finding, because now we already have this matrix. This matrix, we have it as our p, our pi naught. What's pi naught? It's the same as having, we're already given to us as 0.3165, yes. Then 0.3841, and then 0.2991. Now, members, I think let us first get the p power 4. After setting the p power 4, shall be able to multiply it with this matrix, so as we get our px4. Therefore, from there, let us first remember p power 4 is the same as having p squared times p squared. Now I think we also can just get p squared first, and then multiply it by itself, and then get the answer. Now, first to get p squared, it just requires us to, I think I need most. Okay, p squared is same as having this matrix we have here: 0.451, 0.288, 0.261, then 0.261, is 0.218, 0.571, then 0.211, then 0.308, 0.226, and then 0.466. This one times the same matrix, 0.451, 0.288, then 0.261, then 0.218, and then 0.571, then 0.211, then 0.308, and then 0.226, then 0.466. Then if we get this matrix, then you shall just need to multiply it by itself, and then we get the p power 4. Now let's just try to see how we can get that matrix. I think shall work together. For any mistakes, you just forgive me, because I'm also calculating from here. But I think shall not get any mistake. We are doing row by column. Get the p squared. Row by column. We have 0.451, yes, into now 0.451, yes, plus 0.288 into 0.218, yes, plus 0.261 into 0.308, and then we shall have our first entry here for 1 is going to be 0.34, I think 7. Just use 3 decimal places, 37. Now also here we do the same thing for the second row. Shall have 0.451 into 0.288 plus 0.288 into 0. I was doing row by column. Yes, I'm doing a row by column. We're doing row by column. I'm doing this one times this one. Yes, 0.451 into 0.288. Yes, plus 0.288 into 0.571. Yes, plus 0.261 into 0.226. Yes, therefore we get our value as 0. It should be 0.35. Yes, 3. Then also here we do the same thing for this row. Shall have 0.5 into 0.261 plus 0.288 into 0.211 plus 0.261 into 0.466, and then we shall get 0.92. So get 0.29. Yes, 0.291, like that. And then I think this the one will continue until we get our p power 4. I think that wasting time. Let me just give you a final answer here, and then we just chill it. Therefore, for me to get the p power 4, I need to do the same steps I've been doing up to I obtain my answer as the p power 4 matrix is going to be p power 4 matrix is going to be, yes, our p power 4 matrix is going to be this one, just from calculations. Then you get this one. Now our task now is multiplying this one times this one so as to get our final matrix. I think if I put off this first, we shall just need to have we shall need to multiply 0.3165. yes, okay, let me just put it here directly here. This is the same thing as having as 0.3165, yes, 0.3841, and then 0.2991. Then what's going to be our final answer? I think now we need to just need to multiply and get to see our final answer. It's going to be this times row by column, 0.3165 into 0.321 plus 0.3841 into 0.317 plus 0.2991 into 0.322. Then our final answer here is going to be 0.3. The probability is going to be 0.31, I think, 9. Okay, take 4 decimal places, 96. Our first value. Our second value is going to be the same as having, now this times this column, 0.3165 into 0.374, yes, plus 0.3841 into 0.381, yes, plus 0.2991 into 0.370, and then our answer is going to be, here is going to be 0.375, yes, 3.75. We want 3 decimal place, 4 decimal places 3. So our final answer is just going to be 1 minus the whole of these ones. Okay. This step, this space is not going to be this. Yeah, I'm going to have just 1 minus these two. I'll have 1 minus 0.3196 minus 0.3753. I'll have 0. Here going to be 0.30, then 51, and then these are the probabilities that on the 4th day it will decrease, remain unchanged, or increase. I think for this question summarizes for what we had in these two previous videos we had for part 1 and part 2. Members, thank you for watching. Keep liking, subscribing, and commenting. I think I'll bring more questions, sample questions on how to do these Markov chain questions. Members, thank you for watching. I remain Stochastic, the math tutor, but members, we still need your help. I think for whoever has anything to help with it, help the channel with, can bring. We need more markers. You see that markers are becoming dull. I want to see them. I think we need a more bigger whiteboard to attract more questions and workings, and then I think we need a lot of things. Members, now whoever who has anything that can help the group with, members, help the channel so as it grows, and because I think you are seeing the benefits of the channel. Thank you for watching. I remain Stochastic, the math tutor. This is just a sample questions. We shall have more sample questions about the Markov chains in the future. Thank you for watching.